First lesson in this chapter is talking about naming solids and nets. So what we're going to do is first kind of introduce some solids. So basically a solid is an object that is not going to lie in a plane. So if we're talking about a solid, we're talking about something that has 3 dimensions. So it's going to have length, width, and it's going to have height. So basically this is saying it's not flat. It's going to be 3-dimensional for us. When we're talking about a prism, so a prism is a solid with 2 congruent parallel bases. So basically prisms are going to be like a rectangular prism. You're going to have 2 bases that are rectangles. It can also be a triangular prism, so you're going to have 2 bases that are triangles. The faces are all the parts that actually connect the 2 bases together. So those faces are all going to be rectangles in our case because they're all going to be right prisms. Prisms can also have parallelograms for faces because they might be slanted slightly. So instead of standing straight up and down, they might be at a little bit at an angle, which would then mean that their sides are going to be parallelograms. Another solid we'll talk about is a pyramid. So a pyramid is a solid with 1 base, and the base is going to be some sort of polygon, be it a quadrilateral, pentagon, whatever. In a pyramid, all the faces that are joining it are all going to all be triangles then. The one that's a solid with 2 bases that are parallel congruent circles, so think about a circle on top and bottom, that one's what we call a cylinder. We also have a cone, which is a solid with exactly 1 circular base. And it also has 1 vertex. So think about the end of an ice cream cone. It kind of comes to a point down at the bottom. That's the vertex that we're talking about. A blank is a solid whose faces are polygons. So this is a polyhedron. So when you think polyhedron, you can think soccer ball because all the faces are made up of polygons. Any side that is not a base is called a lateral face. We'll pretty much just shorten that and just call it a face in class. An edge is where 2 faces meet, or a face and a base where they can meet too, because that's an option. A vertex is where 2 edges meet. The last definition here is the word skew for skew lines. Skew lines are lines that don't intersect and are not parallel, but they're in different planes. So basically, if you think about a box, we need a little bit of propage here. So high C container, right? If you think about the high C container here, we have, this would actually be a rectangular prism. This line across the front and this line across the top here, those are actually going to be skew lines. You'll notice that they're not in the same plane, and when I talk about plane, that basically means can I cut that with a piece of paper, and I can't. So this line right here and this line right here, those are going to be examples of skew lines. They're not parallel because they're not in the same plane, but they're also never going to intersect each other. You could also have this one across the back and this one across the front right here. That would work. However, this one, and let's say this one in the back here, so looking at it from the top, in the back, those would actually still be parallel because think about it. Those 2 pieces, I could put a piece of paper through the high C kind of at a diagonal like this, and that would actually, it would cut through them and they are parallel then, okay? So that's kind of your example with talking about that. In the next one, so in the figure below, we need to name the figure, describe the base, name the figure, and label the part labeled CD. So we're going to be looking in particular at CD here. So this base is kind of missing something. It does need little right angle marks in it. That's something that I did not put into it for you. Since it doesn't tell us anything about the sides, we have to say that it's just a rectangle then. So since it's a rectangle, this is a rectangular pyramid. And it's a pyramid because all the faces, all these parts around the outside, are all triangles. And they do come to a vertex, a point at the top. Side CD is what we are going to be calling an edge, because it's actually where the base is meeting one of the faces then. Okay? Next part into our lesson, talking about skew and parallel lines in the picture. So going back to the high C container, skew lines we could have, for example, AB, since that's kind of going up like that. And if we look at AB, we need something that's not parallel but not going to cross it. We could look at CF right here across the front. Starting with CF again, if I were to try and name a parallel segment, I could use AD, or I could even use BE because they're both going straight back and forth. I'm just going to use BE since it's right up top there. Okay? Take a look at these last two examples, come back and check your answers. So here in the first part, the base is an octagon, it's an octagonal prism. In number 2, part A, those lines are skew, and part B, those are parallel. We're going to talk briefly about nets. So basically nets are what we call shape jackets. So a shape jacket is a flat, two-dimensional, and it could actually be folded up to create the 3D solid. So kind of think about if we were to take the high C container and we were to make some cuts here and just open this and actually lay it flat, lay the actual container itself flat. Just to kind of help us recognize some nets, prisms and pyramids are kind of separated in nets. They are two different things. So prisms have two identical bases and they're connected by rectangles. So the nets for prisms have two bases, which kind of looks like little tabs on the end, and they have lots of rectangles. It's kind of a way for you to be able to pick the prisms out. We name them then by the bases. Pyramids are going to have one base, and they're all going to be connected to a point by triangles because all the faces are triangles. The nets for pyramids are sometimes going to look like stars because you'll typically have the base in the center, and then you'll have all the triangles going around the outside, so they kind of start to resemble stars. If we go through here, we're just going to look at the pictures. We're going to name the nets. So this one, notice the two little tabs here. They are going to be considered rectangles. So this is a rectangular, and it's a prism because there's all the rectangles connecting it together. In this next one, our base is here in the center. We have a square. And we have triangles all around it, so this is going to be an example of a pyramid. If you were to fold them up, they would form a pyramid. This one has all squares that are all the same size. That's a special one that we call a cube. This one, you'll notice again, has kind of the little tabbies. They're pentagons, so we call this a pentagonal. And it has all the rectangles that are going to fold up and create a prism for us. Down here, started looking like a star. 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon for a base, so we call this an octagonal pyramid. In this one always throws people off. Put a star next to this one. Your two tabbies are triangles, so this is a triangular, and it's a prism because it has rectangles holding the two triangles together. The next page, the one up at the top here, has a triangle for a base. It's right here, and triangles to connect it all together. So this would be a triangular pyramid. And in this one, you notice there still are the two tabs here. And even though they look like squares, we saw this one earlier, we don't call it a square prism, we still call it a rectangular prism, regardless of whether those are actually squares on the ends. It does have all rectangles to join it together. Here we have a hexagon base, so this is a hexagonal, and it has triangles to join it all together, so it's a hexagonal pyramid then. Last one, we have two circular bases connected by a rectangular piece in the middle. The two circular bases tell us that we are talking about a cylinder. So if you think about circle on the top and bottom then. Okay? And that's the first lesson.